From the single copy function we created in the previous chapter, we are now going to dive deeper into Fox. In this chapter, we are going to look at variables, loops, internal tables, and how to debug Fox. Fox code generally follows the following structure. The data declaration must be performed before the operations. We define a variable and type the variable as a predefined types. Any info object can be used to type variables or some other predefined types, such as key figure values, integers, or dates. In the parameter screen, we can display the available data types by clicking on the Data Types button. Data type F is used to temporarily store the value of a key figure. In the previous copy function, we can assign the reference data to a variable and use this variable in subsequent calculations, for example, adding 500 to the reference quantity. This value can then be assigned to our target area. This makes the code less verbose. Operations are generally in the format of key figure name and then various info objects. And these info objects are the info objects to be changed. So if I go to characteristic usage, the fields to be changed are the info objects in the statement. Remember that the values in the operation on the left-hand side of the equal sign must be in the filter, and the operation on the right-hand side of the equal sign in the reference data. This roughly corresponds to a to and a from, where the reference data is typically the data that we read from, and the data target is the area that we write to. Next, we're going to look at variables and loops. The requirements from our customer state that actual volumes from COPA will form the basis of our future planned volumes. The average volumes of the past 12 months should be written to the planned values for the next 24 months. I've created an ad hoc report showing that the values for 2018 sits in version 0 value type 10, and we want to copy it to version 100 value type 20 for 2019, and at the moment this intersection is empty. So if I run my planning sequence, we can see that the averages has been copied to 2019 based on the variables of source 010 to target 120. So let's look at the setup. From this requirement, 4 fields must be changed and assigned to variables as follows. We've got our target variables assigned to our filter and our source variables assigned to our formula. Looking at the system, our filter contains our target variables as stated, and hard-coded is the target info provider. Going to our planning function, 4 fields are changed, the fiscal year period, info provider, as well as version value type. Now looking at the code, it starts off with the data declaration, and then we have a key figure value quantity. We assign our variables to fields within the Fox code, so our source version, SS version, target version, T version, and so on. A good first step is to clear our key figure value. Then we loop through each value in our variable source fiscal year period and assign it to sFiscPer. We assign that value, which is our reference data, to our key figure quantity, and we escalate this value, accumulate this value with every iteration. We then calculate the average, and then again we loop through our target year fiscal period, assign it to tFiscPer, and write it to our target info provider. Let's look at the results of the Fox by running it in trace mode. So first the variables, I'm copying it to version 100, value type 20 for 2019 from 0/10/2018 and executing it. We can see that 240 records has been generated, and looking at a block, it shows that 2018 is my reference and 2019 is the new records that has been written to. So I can save the data. In the previous example, we assumed that the user will always and correctly choose 12 periods. But what if the user wants the flexibility to choose any number of reference periods for the calculation? In this case, one option is to get the number of variable values in the variable source FISCPer and perform a loop based on a counter. Two new variables will be defined. One to store the number of values in the variable source FISCPER, and the other to act as a counter for a do loop. We get the variable value from source FISCPER for each loop where the index in the source FISCPER is equal to the counter. Now let's look at the code. The first section of the code remains the same. However, we have two new variables, C and N, which will act as indexes and counters. So N will be the counter, and we initialize it as 0, and then we read the number of variables in source FISCPER by using the varc function. So if there's 12 values, N will be 12. And then we loop 12 times through the values in source FISCPER. And because C starts at 1, we read the first value, and then it increments these values all the way to 13. However, we'll only be using it 12 times. Now, we could have used a for each loop as well, but I'm using the do loop to demonstrate the functionality of the do loop. And then the rest of the code remains absolutely the same. However, the change is that we're dividing the quantity by N, which is the number of values in the source FISCPER variable. The next step in the planning application is to create some average prices by material group. The average price will be the average price of all material group customer prices available. Only when there is no price already available for the material group will a new price be created. In order to prepare for the function, some prices has to be planned, and I've already planned some prices. For prices by material group, I've planned for L4 and L1, and prices by material group and customer, I've planned for L1, L2, and L3. So in our case, only prices for L3 and L2 has to be created, and the price for L1 remains unchanged. The syntax for creating an internal table is as follows. Specify table, itab, my table identifier, followed by the key fields, the data type, and specifying it as key, followed by the key figures, and then the non-key fields and their data type. To assign a value to an internal table, we specify the table identifier, followed by the key figures and the rest of the fields. To access a value, we specify the table identifier, the key figure, and the fields. Note that there might be more than one key figure in our internal table. However, we can only access key figures one key figure at a time. Now let's look at the code in more detail. The definition of the internal table contains three fields: the material group as key, the amount that stores the prices, and the count that stores the number of records. The system selects reference data as everything to the right of the equal sign, and we accumulate the existing price with the prices that's already in the internal table. We also increment the counter by 1. Next, we loop through all the material groups in the internal table and get the number of records. If the number of records are not equal to 0 and there's no existing material price in the info provider, we write the average price as calculated by the prices divided by the number of records to the database. Now let's look at the results of the code. I'm running it for version 100, fiscal year period 2019, so the same values as planned in my input schedules. And the trace results show that new records has been created for L002 and L003, but L001 remains unchanged. So the after and before images remains the same. Debugging Fox code might provide insights on why your code might not be working as desired. In order to debug code, we simply add the statement break point to the desired line in the code. When we execute the code, we can check the value of variables by simply double-clicking on them. So if I want to look at the content of my internal table, I simply click on itab, and then I can see the value of the material group, amount, and count. And as we continue with execution through the various points, we can have a look at how the values accumulate, the count, and the amounts, and so on. In this chapter, we did a bit of a deeper dive into FOX. In the next lecture, we're going to look at characteristic relationships.